what did they say? Decimals. Repeating decimals. Okay, this comes about, ladies and gentlemen, when you have some fractions. Some fractions, you know what their decimal equivalents are right off the bat, right? If I gave you 1/4, make this a little bigger. Actually, let me make this a little bigger. Uh-oh. If I gave you 1/4, that seemed blurry.
Yeah.
1/4 is what as a decimal? You probably know that because it is a quarter of a dollar, which is what, Alex?
0.25.
0.25. Well, 0.25. 1/5, maybe you know is what? Landon? 0.2 or 0.20 would be fine, 2/10. But sometimes you come across fractions like this, 1/3. Now you probably know what 1/3 is a decimal, but if you didn't know what 1/3 was as a decimal, how would you change 1/3 to a decimal? I'd say to a decimal a few more times. Cabran, what would I do to change this to a decimal? Divide what? Right, you divide the bottom. How nice that writes. Bottom into top. And you take 3, divide it into 1, and a glorious thing happens that only few people understand. I bring my decimal up here. 3 doesn't go into 1, but 3 goes into 10 3 times, correct? I subtract, and I get 1. I bring that down. Now 3 goes into 10 how many times? 3. 3 times 3 is 9. I get 1. Bring down my next number here. And you know with decimals, you got to keep going until they work out, which means you're going to spend the rest of your life doing this problem because as you can see, you're going to keep getting 10s, subtracting by 9s, 10 subtracting by 9s. So this is when we get the repeating decimal. And rather than having you write down 3s for the rest of your life, somebody said, well, let's shorten that a little bit and do what? What do you do for repeating decimals? David?
Put a line over the repeating.
Put a line over the digits that repeat. So 1/3 should look like this, 0.3 with a line over the 3. Now, is it acceptable to do this, or would it be the same thing to have 0.33 and then both of those repeat? Yes, it would be the same thing, but the acceptable way is only to put it over the ones that, the beginning of the repeating, otherwise it gets a little complicated there. Okay? And there are some that you should probably become familiar with, and I'm actually going to give you a little piece of paper as a helpful little thing, because you probably won't remember them unless I do. Alex?
How would you put the 33 and 1/3%? How would you do the 1/3 percent for the decimal?
As a percent?
Yeah, for
Well, if it's a percent, I would write 33 1/3%.
I mean, converting it from decimal to
Well, you'd multiply 33 1/3 by 100, and you'll end up with your 1/3, I believe. Or divide it by 100, and you'll end up with your percent divided by 100. It's a long process that we'll get to later, but you would divide it by 100. How'd it go, Nick?
good.
Good.
There's my links.
Gotcha. Perfect. So we'll get to that later, percents and that whole thing. Now, it will be well and good for you to know these. 1/3. You should know the thirds, the sixths. I don't think we necessarily do the sevenths. The eighths and the ninths. 1/3 and 2/3. 1/6 and 5/6. 1/8, 3/8, 5/8, 7/8, 1/9, 2/9, 4/9, 5/9, 7/9, and 8/9. Those are all common fractions that you should know their decimal equivalents, all of which are repeaters. Now you might ask, why didn't I put 2/6, 3/6, or 4/6 up there? No, they do repeat.
Why didn't he reduce?
Yeah, if I would put 2, 6, 3, 6, and 4, 6 are the same fractions as 1/3, 1/2, and 2/3. So they already, you know what 1/2 is, and 1/3 is gonna come up here, 2/3 is gonna come up there. Let's shoot down the ones that we know. How many of these do you actually know what the repeater would be for those? We just did 1/3, right? So 1/3 is 0.3 repeaters. 2/3 would be double that, which is 0.6 repeater, correct? Good. Does anybody know any other ones? Actually, they don't all repeat. The 8s don't repeat. Anybody know what 1/8 is as a decimal?
12.5.
Well, it's 0.125. So 3/8 is, multiply that by 3, 0.375. 5/8 is anybody? 625. And 7/8 is 0.875. Now the other ones do repeat. And what are they? Let's do 1/6. If I take 6 and divide it into 1, let's see how long it takes before it repeats. 6 goes into 10 how many times? Once, thank you for. 6 goes into 40. 6 times, which is 36. Subtract, I get 4. So what's going to start happening? You're going to get 40. So how does that look as a repeater? Logan?
0.16.
Line over what?
16.
This one doesn't repeat. It's only the 6 that's going to repeat. So it's going to be 0.1 repeater 6. Oh, and by the way, the thing we learned today is the repeating digits are called the repetend. Repeating digits are called repetend. A repetend. I guess that makes sense. What is 5/6 as a decimal? If I take 6 and, well, it'd be 5 times that. But let's do it. 6 goes into 50, what? 8 times is 48. 6 goes into 20, how many times? 3 times, and it's going to keep getting 20. So the repeater for 5/6 is 0.8 repeater 3. And guess what the 9ths are? Does anybody know what the 9ths are? The 9ths are the best. David?
Whatever the top part of the fraction is, that's what's repeated, so 1/9 be 1 repeated.
Right. 1/9 is 0.1 repeater. 2/9 is 0.2 repeater. Why don't I have 3/9 up there? Because 3/9 is 1/3, which is 0.3 repeater. 5/9 is 0.5 repeater. 7/9 is this, and 8/9 is this. And I've got a sheet that I'm going to have taped on your binder. That's what, Rob?
4/9.
Oh. Try to sneak that by you. That should be 4. Right over here. I thought I was wrong once, but I was wrong. So they're going to do this. They're going to not only ask you about this, but they're going to give you the repeater decimal, and they're going to ask you, they're going to say 0.8 repeater 3 is what fraction? Question mark. To which, how are you going to know what 0.83 repeater is what fraction? Yeah, you're going to look on the sheet, because there's no way. We do at the end of your book, we get how to change repeaters into fractions, but it's kind of a complicated process. So when you're asked this question, look on your cheat sheet. By the way, well, let's talk about those. Maybe should we talk about it now? So, yes, I guess we have to, because I just saw it in the book there. Everything we talked about today is what's called a rational number. Okay, because they do make sense. Repeating decimals do make sense because you can, like I said, it's a hard process. You can change every repeating decimal to a fraction. Every repeating decimal has an equivalent fraction to it. Now, if there's rational numbers, there's what we call irrational numbers. And irrational numbers are never-ending decimals that don't repeat. Okay? And an example of that is right up there in pi. If you look at pi, people have done that out to, I don't know, 10,000 digits, and it never repeats, and it never stops.
Really?
So, if you see irrational numbers are numbers, don't get those two confused. They both can be decimals. Come on with that ring fork. Stop. Hang up. Go.
Stop ringing.
So everything we're talking about today is rational because it does make sense because we can make a fraction out of it. But pi doesn't really make sense. I mean, we can get close to it, but we can never get perfectly exact because it doesn't come to an exact ending. So with that being said,